What's going on, everybody? Feder here from 3D Print SOS. Welcome back to the channel. And in today's video, we're going to be talking about a pretty exciting machine, at least for me, the Flying Bear Reborn 2. And it is actually off screen a little bit right now because it is finishing up some prints while I go ahead and do this intro. And I'll definitely take the camera and show you around while we go ahead and explain everything that we're doing here. I actually unboxed this machine as well as assembled it in a live stream. It should be popping up right over here, as well as I'm going to play some video off to the side, some shorts that I did with the machine, just to give you an idea for everything that I've done so far while we're over here introducing it. But essentially, this is a very large CoreXY machine that uses linear rails and linear rods on the X. Uses large 12mm rails, not 7s or 9s. They're very, very large and stout. It has an all-metal hot end. It has decent cooling. It has a very interesting extruder. And the cool part about this machine is its print bed is 329 by 329 by 350 millimeters. That's the print area that you're able to print. So you can make giant things. Just to give you an example right off the bat, this was the first print off the machine. And just to give you an idea for the size of this, here is a Voron V0 that we're building on a live stream. And as you can see, the print bed area on this printer is bigger than this entire printer. Obviously, it's a small printer, but this is definitely an absolutely massive amount of print space. And the cool part is, even with that print space, there's space on the inside to put at least 3 spools. So if you're going to be printing ABS or ASA, you could, for example, put those spools on the inside of the machine and have them always warm and ready to go and dry. So there's actually use for all the space that's in here that this thing takes up. It has some quirks. But for those quirks and for the compromises that you might have to put up with this machine comes the price tag of $390 shipped. So it's a very affordable machine with components that you can get anywhere pretty much, whether it's Amazon or even some places locally. The only kind of main quirk is that it runs Marlin standard. So for me, I saw this as an opportunity to purchase a Raspberry Pi or a CB1 or an MKS Pi and add it into here to run Klipper and just to see what this machine is capable of. It actually uses the larger belts as well, so that we know that this thing is capable of doing something fast and hot, right? Because it's enclosed. So I've been running tests for about 2 weeks, and I've been having a lot of fun. I've obviously printed PLA, I've printed ASA, ABS, TPU, and PETG at the moment. That's what's finishing up, and all of it has been printing perfectly fine. I went through Ellis's guide and did the calibrations for Klipper, input shaper, linear advance. All of the fun stuff has been done, and now it's working really well, and I'm just excited to share all the work that I put in for this machine. So just as a disclaimer, Flying Bear did send me this machine for free. They didn't pay for anything. I'm not obligated to say a thing. They're going to be seeing this video at the same time as you guys are. To be honest, I've kind of been just enthralled with just tinkering with the machine again. I've been doing a lot of reviews where I unbox a machine and then I just print with it, because sometimes I can't do anything to it. Sometimes I don't want to do anything to it because it's just done, or it is the way that it is. But this just, it begs to be modified, and that is something that I usually really enjoy doing, and it is just right up my alley. So my plan for this video is to turn the camera around, kind of take you through generally what the machine is and how it does things, and then show you the modifications that I have done. So for running Klipper, I chose to do a Raspberry Pi 02W. It was one of the originals that I bought as soon as it came out for $15. Obviously now they're a little bit more expensive, but you can buy a Raspberry Pi for 1 gigabyte, which is perfectly fine, for around $35 right now, as well as a CB1, for example, an adapter, or a Big Tree Tech Pi. I don't remember what the Pi version of it is called. They're around $36, so they cost about the same, and they're just as capable. Just make sure that you get the version 2.2 of this. And the reason why I say that is because I was able to hack the front screen to run ClipperScreen. So the screen that already comes on this machine can in fact run ClipperScreen, which gives us the opportunity to, you know, not need a computer or phone or to go to our front end to do simple things like filament change or just warm something up or run a custom macro to do whatever you might want to on the machine. So, like I've mentioned so far, there's a lot that can be done with this machine. It lends itself really well to tinkering. I don't think this is going to be for everyone whatsoever, but at this price point, this reminds me of that original Aquila when I first got it, where I saw that it was under the cost of an Ender 3, but had the same capability, and you could upgrade it to make it do all sorts of stuff. It gives me that same feel where this is definitely an underdog machine that doesn't get utilized or talked about. And obviously right now there's a ton of amazing machines out there that you can take out of the box and just endlessly print flawless prints. I get it, there's a place for those, but not everyone has the kind of funds that are required to run those machines. Even the middle of the road machines, still around $500, $600, $700, whereas something like the X1C is $1,200, $1,300, $1,400, $1,500 with, you know, multicolor units. So very expensive machines, and this being under 400, well, it just feels like a lot of fun to me. So let me get the camera, let me turn it around, let me show you what this thing is all about. Let's go.
All right, so first things first, this thing is just an absolute mass. You can fit so many things in there, and one of the things that I actually really like about it is, like I mentioned before, you could definitely fit some spools behind here because the bed is actually much smaller than the printer itself because of the CoreXY structure. So there's actually modifications to put spool holders inside so you can hang your spools in the back, which I think is a very good use of space because look how big it is. And hello, there's my reflection. But either way, here is the screen running ClipperScreen, and we'll flip over the machine later and I'll show you how I set this up. But as you can see, it's a decent size. It's not the biggest screen, it's not the smallest screen. The buttons are somewhat small. Like for example, let me give you an example of printing. So here we have a bunch of files that I have in there. So you can see it's doable, it's pressable. Like for example, let me hit this file. See, there's like a little misclick here, a little misclick again. Come on, there we go. Now we got it. So there is some quirks here and there about the screen, but still, this is so much better than not having anything. For example, if you want to extrude, once you have temperatures, you have this menu. That makes it easy. That way you don't have to go on your phone or set anything up. If you want to just set some temperatures, it's pretty easy. You can get to your macros with this button. So, like, you know, it's still much more useful to have than not to have, and it's already on the machine and essentially free, so that's nice. In the front here you have your USB and your SD card. Although the USB is nice to have, obviously, it's still kind of weird that they put it here because, well, when you close this you can't really use it. So if you want to print ABS, for example, or ASA or similar, and you still want to use a device like a Raspberry Pi or whatever through USB and not through UART, or maybe even like a Sonic Pad, for example, that doesn't have it an option, you're gonna have to maybe get like a 90-degree bracket and run it some other funky way, or you're gonna have to drill through the door. So that's kind of an odd placement, but as you can see in our case, that doesn't really matter. If we head over here to the top, let me just show you a couple things here. So first of all, up top here we have two Z motors, and the reason why I want to mention that is because most CoreXY machines that I have here run these under a single motor with a belt system. Here they're completely separate. So much like the Voron Trident with 3 points, you can do Z tilt on 2, so it automatically probes one side, goes to the other side, probes here, and then uses that algorithm to make this as even as possible by itself. So that's very nice. Everything is metal here except for, you know, the panels. The panels are all kind of floppy plastic, but that doesn't matter because the extrusions are good and stiff enough. The machine is nice and square. In the top here we have our 329 by 329 build plate, which is double-sided PEI, and I highly suggest you get PEI over just glass. One of the additional quirks here is, as you can see, there's no metal in the build plate. The build plate is actually a piece of glass that you essentially put your magnet sheet on. So there's some benefits there, there's also some downsides there, but it does work. It is insulated and it is really flat. I have no weird spots in the mesh. The only only thing you can see in the mesh is just you know, the unevenness of the tilting, but that's what the mesh is for. It does have bed springs on all corners, so that is that. It uses really standard motors, as you can tell. As far as all the way up here, we have 12mm rails, so not 9, we have 12. They're huge, and we have these significantly larger belts than what I am used to, probably because this thing is so big. So it is really robust, and obviously it looks like it lends itself well to going fast. So we have definitely been testing that, and I can attest that this thing can print 200 plus pretty easily. Now the tool head is really heavy. This whole thing is a block of metal, and I have seen several modifications to use a stealth burner, which might actually be probably your best bet in terms of modifying this machine, because it would be significantly lighter than this, and even then the stealth burner itself is really heavy, so you can go much lighter. There's a lot of room for improvement, but as it stands, this hot end tested actually managed to get around 16 millimeters per second on the max flow test, and which is really good. It's actually more than my current Trident setup right over there, so it can actually flow quite well the way it is. The extruder seems to keep up, the heat block seems to keep up. I've had no problems, and the cooling is okay. You can definitely have better cooling with larger fans, but this seems to be just fine, especially if you're going to be using this enclosed with ABS and ASA. You're not going to need that much cooling in the first place. But the hot end itself, all of this is definitely okay to start. It's actually pretty good to start. There's only just room for improvement here. The other thing that I need to mention is probably one of the biggest downsides of this machine is they use this as the leveling sensor. This is pretty much only good for using as kind of like an optical end stop, but they use it here as an ABL, and I have been having a lot of trouble getting it to properly work because it actually doesn't like it to be hot. So anywhere past 60 degrees, it just needs to probe the bed significantly more. It's not quite as accurate, and as you can see by that line, I've had some well, some contact because just the inconsistencies of this ABL. So my suggestion would be is to either just go manual to start and then get something like a BL Touch, a CR Touch, or the BQ sensor. There's so many out there now. There's lots of mounts for all of those probes, and they will all work so much better with this. And since you're running Klipper, they're very easy to set up. But in the way that I have it, this is manageable, especially if you're going to be printing lower temperatures. If you print ABS and ASA with this sensor, you just have to watch that first layer, as it's just a little bit too inconsistent for comfort. And that's really its only main negative, other than, well, just being the largest printer that I have here in the studio. Everything else seems to be solid. So outside of this, and outside of what you probably saw in the live stream, if you haven't, I'll put another link right here to the live stream where we unbox it and then assemble it and then some first prints. I'm going to go ahead and flip this over, and I'm going to show you how I set this up for Klipper, because I do think it is a really neat setup, and it's very clean because all the hardware is nice and tucked away in here, and it just with very little modification, very little money, you can have this running Klipper, printing fast in this giant CoreXY configuration with tons of room for improvement. Alright, that's enough. Let's flip this thing. Let me show you what. One thing I wanted to quickly mention is I wanted to praise them for putting the spool holder onto the front side of the machine, which means you don't have to go in the back or somewhere far on the side there and reach anywhere. The spool is literally right by the front door. It makes it really easy to feed filament and change filament, so that is really nice. One thing to note though, as you can see I put some tape on here, is this right here is just kind of an abrasive material, and it doesn't glide really well on the spool, but this tape fixed that problem. There's also a printable mod you can put here. You can obviously modify this in any way. It's just drilled into plastic, but just worth noting that this is another kind of gotcha, I guess, or another compromise, and that's why this thing is so cheap, is just this metal spool holder doesn't glide very well, but this tape really does fix it. But still, this design, the way that you know, for the size of this machine to have the spool right in the front, very good. Alright, let's keep going. Alright, now that we got it all flipped, I just wanted to show you how neat and tidy everything looks when it's all put together with its cover. It's just minimal, and I like it. They didn't go overboard, and it's simple and cheap and modifiable, which is nice. Let me get this cover off. Alright, so here is the bread and butter of the whole machine. We are using a Raspberry Pi 02W for this particular build. You can fit any Raspberry Pi or the like inside of this case. There's definitely plenty of room. I just had one of these on hand. It is more than powerful enough to run Klipper and has full GPIO pins, which we need, as you can see, to repin the stock screen. I'm not going to go into too much detail about the pins. I'm just going to show you the wiring that I use, and then down in the description I will have step-by-step instructions that I used from other people and their tutorials that I followed to get this running. It actually makes it really easy if you just follow one at a time. So right here, the Raspberry Pi, as you can see, there's no other connections other than the GPIO pins. We have two of these wires right over here running to where the Wi-Fi chip used to be, and that allows us to run this in UART, which means that's how the Raspberry Pi communicates with the motherboard. It also gets power from one of the plugs right over there. There's a 5-volt dedicated plug on the board. That's this black and white wire going to the UART as well. So that's how it's getting power. So everything you need is already here just with these wires. That's how it communicates. You don't need any power supplies. You don't need anything funky. And then the rest of all of these, this ribbon cable that I didn't take apart, I just went ahead and split those and repinned it based on the diagrams that I saw. So run in UART to get it to communicate with the board. Remove the Wi-Fi dongle because you won't need it, because this talks to this uses Wi-Fi to talk to the machine. So remove it, connect it to UART, then repin the screen, install KlipperScreen, and you're good to go. It's really that easy. So like I said, I'll have links down in the description on how you can do that. Also, I guess while we're talking about it, I'm also going to include the 2 files you need to run Klipper on your machine. I'm going to run the actual bin file that you need to flash to your motherboard. You just throw that bin file onto an SD card, plug this thing in, and the screen will turn off. The stock screen will turn off. That's how you know you'll be running Klipper on the board. And then you're going to need a configuration file. After you have Klipper running on your Raspberry Pi, you just use that configuration printer.config, and that will have all of your settings if you're using the same thing as me, which is that stock probe and the stock setup. If you're into Klipper at all, or even not, if you change the probe, you just have to change a couple parameters, nothing major. But other than that, the only other major thing that I did is I am running all of these stepper drivers in UART mode. So the way that you do that is you remove this. Let me see if I can do it by the heatsink real lightly without taking anything apart. There we go. As you can see, I just had to move this little pin over from up there and then remove another one. Alright, so the point of doing UART on those is you just get all the control that you want through Klipper, which means if you want to change the voltages or certain other parameters, like how many steps, things of that nature, you can easily do that through the configuration without having to do anything manually. You don't have to tweak the potentiometers on here or do any crazy calculations. You can do all of that through Klipper itself, which in my opinion, the least amount of times I want to take this off is the better. So that's why I chose to do that. You can comment out all of the stepper driver information and just keep this the same and let the board do its thing. It also works that way. I have tried it. So other than those things, putting this in, repinning the wires for the screen, taking out the Wi-Fi and running some wiring, all of that is completely stock. Nothing's added, and these used to be $15. I realized they're not. I actually saw that Raspberry Pis are coming back, and for around $45 you can get a Raspberry Pi 2B, which is fantastic. It's about the same power as this, and you get the full-size Pi. And like I said, if you flip it that way, there's plenty of space to put in here in a case. And the beautiful thing about it is this fan is actually powerful enough to put in enough air that you don't need to have any cooling. A heatsink would obviously be nice, but as what I've noticed so far, this does not go over around 40-ish, maybe middle 40s, which is perfect. So it's definitely getting enough air down here. Let me show you some of the other things you can do if you don't want to repin your stock screen. I have some other options and some other things I tried. So let's go back to the table. Let's go over the prints, some of those options, and then we'll get into the conclusion of what this thing is all about and what I actually think. Alright, let's go. Alright, so these are the other things that I tried to get the printer running Klipper on. The first was my CB1, and this is probably your cheapest bet. This goes for around $36, and the reason why it's not in there currently is because mine is actually version 1, and to run KlipperScreen through the GPIO pins you need at least 2.2 or 2.3, which are the newer models, but that's what they're selling now. So if you go to buy a new one now, you will end up with a new one, with a fresh one, and you'll be able to run KlipperScreen on it, which this should, it shouldn't be impaired like mine. But outside of the screen, this thing ran just fine. That's how I did most of the configuration, is using the CB1. So if you already have one, or you want to pick one of these up because they're really nice for other projects as well, that will totally work. The other option, a little bit more expensive admittedly, but this is definitely for those people that don't want to modify the stock screen. Although nothing's permanent, you're literally just removing wires and plugging in new wires. Nothing is permanent. This is the MKS Pi. As you can see, this one's version 1.1, and essentially this doesn't have a full GPIO pin. It has a bunch of different pins, but it also has other things like a screen. So for example, you run this little cable to here, and now this already has that screen. You can just remove the stock one and use this one. It is already pre-installed with KlipperScreen, so this setup is significantly easier. You don't have to splice anything, you don't have to cut anything, you don't have to buy any breadboard wires and mess with connectors. So this is definitely the easier route. As you can see, UART is right over here, so you just need those two wires and then get this thing power. And the reason why I say that is because this has a 12 to 24 volt power input on it, so you can just run a wire from the power supply. So technically, if you wanted the easiest possible way to get this machine running, it would definitely be this setup, but this costs around $60. So this is around 60 bucks, this is around 35, around 45 for a Raspberry Pi at the current moment. I think I'm gonna have all of this linked down below. I still think even at $60, this is still a very cheap thing to do to your machine to get it maximum performance. Like I said, I think it's currently printing at 200 millimeters per second, perfectly fine with almost zero ringing or ghosting, and it could even be tuned even more. So that's the beauty of it. The only other thing you'll really need is an ADXL. So here is my ADXL setup, and Nero 3D actually has a really good setup video on how to make this happen. This is the ADXL sensor itself, and I have it on a mount. This one is for a afterburner, but I just use double-sided tape to attach it to the Reborn 2 there, and the other end of this Cat 5 cable actually goes to a Raspberry Pi Pico, and this is the brains of the operation. It allows me to use that sensor as a USB. So that's all the point of this. You can run these ADXL sensors directly to the Raspberry Pi's GPIO pins, then install it all the same, and it will work just fine. Mount this wherever you want on your head, or if you want to have it removable like me so that I can use one across many printers and have USB, you need a Raspberry Pi Pico. I'll have a link for Nero's video, how-to video, which is what I followed to make this happen, and I've been using this for a while now across many machines, and it works really, really well. And the point of this is what gets you input shaper. This lets you print much faster than before with many less artifacts. You also don't have to set it up this way. You can buy a USB ADXL sensor that are already pre-made. This is just a way to save money, or if you already have some hardware laying around. So there's definitely multiple ways to do this. They already come pre-wired, even if you wanted to buy one of those. Lots of options, but an ADXL goes a long way. Alright, one more other thing to go over real quick is the test prints and configuration prints. So let's talk about that. Alright, so after you have your machine set up, it's time to do some calibrations, and I did these with Orca Slicer, which is my current go-to. But this is our linear advance adjustment, and what this does is it prints this file, and as you can see, it goes from really sharp at the bottom here to really loose corners, and it actually gets a lot worse on many other machines. I think this handled it very, very well. So we were able to get the best corner somewhere right over here, right before it gets a little bit dodgy. So you want it to be sharp but not too loose and not too sharp, which is right in the middle here. And this was a really easy calibration. Like I said, I've done a bunch of these on other machines that got really sloppy up top, so that means this machine is really good with the flow. The hot end is actually really capable. Then to test it to the next level, we can do the max flow calibration. Some people call this the racetrack, and what this does is it starts kind of going slow, and it just extrudes a nice even path all the way around. You can see these notches. I believe I was going up from 5 or 10. I don't exactly remember off the top of my head, but whatever it ended up being, this was around 16 millimeters. I think it's squared. Actually, I don't remember it off the top of my head what it actually stands for, but it's the maximum flow of this nozzle was 16, or not nozzle, of this hot end was 16, which is actually not too bad for what this is. And you can put that into Orca slicer, and it will stop limiting the speed of your machine, knowing that how fast this machine can flow. And you typically want to stop it when things start breaking up, as you can see at the top here, and then just like with the other measurements, you measure towards the top and calculate it. There's lots of how-tos on how to do that. And then there is a benchy with those settings. So the only flaw that I saw here is the hull line right over here, but that is also easy to fix. But as you can see, the cooling exceptionally well for this particular print, and I believe this was under 50 minutes, so we can obviously go much faster. It's not perfect by any means necessary, but it's still a really good benchy for what it is, and I'm really happy with it. The rest can just be tuned. So let's talk about the box right under this. Alright, so this is what I decided to print on this machine to test it out. I figured I need some of these to hold some hardware, maybe some screws, because what I'm using now is just not working that well. And this is basically using the Gridfinity system, and this is almost maxing out the build plate. I could have technically gone 7x7, but I went 6x7. I'm not exactly sure why. I should have just done 7x7. But this prints in one piece, nice and smooth. Huge print, but let's pop this open and I'll show you what's inside. So this is the Gridfinity system, and the reason why you see all these colors is I wanted to differentiate some different types of materials. So this red right here is actually ASA, as you can see, printed perfectly smooth. I know these aren't necessarily the best prints, but this is functional and what I would actually use, so I wanted to kind of do it that way. This right here is ABS, absolutely perfect. This right here is PETG, as you can kind of tell by its transparency there. These are all, this row and these rows are all PLA, and once again, absolutely perfect as you would expect. There's no ringing, there's no ghosting, it just prints really well. And just for kicks, I even printed them in TPU, and look at that quality. So it can print all kinds of different materials, it can print really fast, it can print these gigantic things in one piece. It has a lot going for it with only a few quirks. Alright, let me put the camera back up and let's wrap this up.
Alright, so let's wrap this up with some cons, then pros, and then just the conclusion. So let's dive right into the cons. One of them is this very interesting and quirky hat that this thing has, the beanie. So as you can see behind me there, the Ghost 6 has a smaller version of the beanie, and one of the things I really like about it actually is you can unpin the front, lean it back up against whatever, or even just have it hang back there, and you can use, you know, your open air for printing PLA, TPU, whatever it might be, and then put it on if you are not using it or want to print, you know, ABS, that type of thing. This machine, this one is too heavy to do that, as I found out, because I broke one of its feet just by letting it hang off the back. And the reason isn't that that's what you want to do with this. The reason why I was doing that is because there's no actually good way to store this. It's kind of big and doesn't fold any further than this, so you have to find a place to store it. I did find after doing this that you can tuck it underneath the machine from the back, and it almost all the way goes underneath and completely out of the way. You just have to make sure that you don't put it all the way forward because it can block that fan under there. Otherwise, most of this machine on the bottom is just dead space, so you can definitely put that there. So that's one quirk. I think one of probably the biggest quirks this thing has is this ABL sensor. this ABL sensor is not good enough to use for an enclosed machine, in my opinion. I had the sensor on one other machine and I had exactly the same experience. It wasn't consistent enough. Sure, you might be able to string together one, maybe two, maybe three automatic bed levelings on the machine, but I guarantee you it's going to eventually dig into your build plate because it's just inconsistent based on temperatures. It likes to do things cold, and when you heat, things expand and more. Either way, I think my suggestion for this machine, if you're going to buy this, is to get two things. It's to get some kind of Raspberry Pi or similar, and any ABL outside of this one. Anything like the BL Touch, CR Touch, or the BQ Micro Probe would be perfect on this, and running it with Klipper would be really easy to set up, and also very useful, especially if you run something like camp, where it would only probe a tiny portion as long as you need that tiny portion. For example, if you wanted to print a benchy on this giant print bed, using camp, it would only probe where it needs to for this and then print, which means you're always going to have a perfect layer. And you can get this thing to work, like I said, somewhat, but it's almost always going to end up in some kind of headache. So definitely a probe. One of the other things that revolves around the hot end is the hot end assembly is steel. It's heavy, and that's definitely limiting its performance, even though in my opinion it's already printing fast enough. You can definitely make this thing go even faster. Its hot end allows you to go faster, and you can do that by all sorts of different ways of printing your own different assemblies. A stealth burner is definitely one option, and readily available. There's two different people that have modified the mounts to mount those systems onto here, and I highly suggest those modifications as well. Although those you don't have to do right away, in my opinion. You can definitely use this machine like this with just Klipper and then upgrade as it goes. I think that's the beauty of it. Some of the other quirks is the screen isn't necessarily any kind of high-end or impressive screen. It is significantly better than nothing, but you can definitely do without it if you don't want to do any of the wiring. You can just run Klipper and then use your computer or even your phone to do any of the tasks. In my opinion, I like to have it here just in case I don't have something right next to me or don't want to click a million times on my phone and have the screen dim, like that type of thing. I think it's nice to have, but other than that, it's definitely quirky. It uses almost all parts that you could very easily find and get somewhere else, so you can modify things, you can tweak things, you can buy yourself and fix as stuff goes wrong, if stuff goes wrong. But it is very robust. Everything is metal where it needs to be metal, and you know, it seems like it's pretty tough for me to talk negative towards it because I naturally just say positive things about it. You do have to figure out space. This thing is just absolutely huge, so one thing to keep in mind for sure. All of the things that I'm mentioning in this video, I'm going to try to keep in the description below as links, not only for you if you're interested in purchasing this machine. The affiliate links there will help tremendously if you go to buy from Flying Bear and using my links, but also things like the probe and some other modifications like the CB1 or things along those lines. If you use my links, it helps out tremendously, so please go ahead and do that. Alright, so just to wrap up, I think if you want a larger machine, if you want CoreXY, you don't have a big budget and you don't mind tinkering, maybe even if you want to tinker, I think this thing is really, really cool. It reminds me of War on Light, if that makes sense. You don't have to build anything. It's already kind of predetermined the setup for you. You're not building it completely from scratch. But it is plenty robust, and I think this platform lends itself really well to modification. You could pretty much do whatever you please. One of the other things I wanted to mention real quick though is that because it doesn't have crazy auxiliary fans or even just really powerful fans, it is actually really quiet. And you can have this thing sitting here without making much noise, unlike, just as an example, the Creality K1 is so loud that I couldn't have it running while recording a video. This is definitely not like that. You could have this thing printing and record video, so that's definitely a major plus. Alright, I think I've talked about it enough. I definitely like it. Do you like it? What do you think? Let me know down in the comments below, as well as check out the description for those links like I promised. Alright, I think that's all for me today, and as always, I'll see you down in the comments. Later.